Hello, explorers, and welcome to Reach the World's Explorer program. For 25 years, Reach the World has inspired youth to become curious, confident, and compassionate global citizens through virtual exchange. My name is Tim, and I'm so glad you're joining us for today's live stream event. You have arrived at the first live event with the Tyrrhenian Continent Ocean Transition Expedition, and we are going to find out today exactly what that means. Explorer Tessa is joining us today from the scientific drilling vessel JOIDES Resolution, which is currently floating off the coast of Italy in the Tyrrhenian Sea and undertaking some fascinating scientific research. Tessa and her colleague Larkin, who is sleeping right now, have already shared aspects of their experience through their first virtual exchange articles, which you can find at the link in the chat. And today we're going to connect live with them and hear firsthand what they have been up to. Welcome to the teachers and students who are joining us today or will be watching this recording after the fact. There's a whole bunch of you. We've got Kittredge Magnet School with us on camera, Falmouth Elementary School, Sharon Elementary School, United High School, Franklin Williams Middle School, Community College of Rhode Island, Perkman Valley Middle School West, Palmer Public School, Museum of Science, the homeschool community in Massachusetts, Honeydew Elementary. We've got a whole bunch of people joining us. It's great to have such a great crowd here. For those of you who are tuning in via YouTube, please feel free to use the YouTube chat bar to let us know you're here, where you're joining from, and of course to share any questions you have for Tessa as we go. We'll get to as many as we can in the next 45 minutes or so. With that, you don't want to just hear me talk all day. I'm going to bring our special guest, Explorer Tessa, onto the screen.
Hi,
hey, Tessa.
everyone. Hello. It's actually nice to hear that there's some Massachusetts schools. That's where I'm coming from, Boston.
All right. We got some Massachusetts connection. All right. But you are not in Boston right now. Can you tell us a little bit about who you are and where you are, please?
Hi, everyone. My name is Tessa Peixoto. I'm the outreach officer, or one of the outreach officers. My coworker currently is on the opposite shift of me, so she's asleep. And I'm on the JOIDES Resolution, which is a scientific ocean drilling vessel that has been in operation for 45 years, exploring the different oceans around the world, trying to get samples of the ocean crust, continental crust, and even mantle to understand what our Earth is like. So we're in the Tyrrhenian Sea for this specific expedition, 402, and we're trying to understand two things. One, how do oceanic crust and continental crust transition into one another, and how do they change? And then also, with the Tyrrhenian plate spreading, there's a little bit of the mantle being exposed and kind of coming out, where typically the mantle doesn't come out in that way. So we want to understand what happens to the oceanic crust when you do have a mantle, some of the mantle kind of like protruding out of it. So we're studying that.
Whew, those are some big questions. And we're going to get really into the science of this. The science is fascinating. And the fact that it's all happening underneath how much water? How deep are we drilling?
Yeah, so our deepest is about 4 kilometers. Hold on, let me look up what that transition is in miles. So our deepest is about 4 kilometers. So 4 kilometers is about 2.4 miles below sea level.
Whew. Yeah, a long way down. Before we get into the science, Tessa, I'm really glad that you're joining us today. I know that you've already told us you came from Boston. I'm going to share some photos of your journey from Boston to the ship, and maybe you can talk us through what the last 3 or 4 weeks have been like for you.
Yeah. So this is the 2 outreach officers on the JOIDES Resolution. I'm on the right and Larkin is on the left. I am a marine scientist by trade and have been working in museums and science education since bachelor's, while Larkin has been a sailor on multiple research vessels and cruise ships for most of her career, and is a science communicator and trying to enter the sort of like science travel business. And she's really, really cool. She's a videographer. So Larkin was coming from Costa Rica, I believe. But she's originally from Kentucky, and I was coming from Boston, and we both flew our way over we both had to have a layover. She was in Munich, I believe, and I was in Paris before we could fly into Naples. This is us with the flag, right with our actual, like a crane in the way of the derrick. So there's a crane right behind us and the derrick is right behind that crane. So you can't really see the derrick. So this was like our second day on the ship when we boarded, and we were just really excited. We wanted to like run around and start looking at the ship. This is my second time on the ship, but her first time. So when I was in Paris, it actually was raining when we were flying over. So I had to like run through the rain to get onto the plane. So that was my plane, and I was where that picture is where the door was. So I had to do a little bit of a run. And then Larkin did not have to run through rain. She just went to a different terminal in Munich. And on our way into Naples, you actually get a beautiful view of Mount Vesuvius. So it definitely made me want to go hike it after this expedition because it's so close to Naples. It's I think it's like a 40-minute drive, and you can go all the way to the top. And it is inactive, I believe, so it's safe to go to that top of because it is a volcano. So that's exciting.
Yeah, we should pause to just talk for a moment about Mount Vesuvius because it's kind of a famous volcano. For anybody who's aware of the story of Pompeii and the burying of the city of Pompeii, that is the volcano that erupted and buried the Roman city of Pompeii. All right, so after that long journey, you made it.
We made it. So we, all scientists had a night in Naples just to handle all our delays. A few people were very much delayed and arrived the day we were supposed to board the ship. And we bussed from our hotel to the port that our ship was docked at. And this is Larkin like taking in the full view of the JOIDES Resolution. You can see our gangway was set out, which is just that ladder. And we had to go up that stairwell into the ship so that we can start putting away our luggages and kind of get settled and know where our rooms are. And we jumped straight into onboarding. We had about 5 days of safety drills and making sure internet works on our phones. And especially for me and Larkin, we needed to make sure internet worked on every device we brought. Because we work on social media and making broadcasts like this and making blogs and other content. So we had a lot of different onboarding things just to make sure we knew where everything was and everything was working.
Tessa, can you talk a little bit about the gangplank? Can anyone just walk on and off the ship while it's parked at the side of the wharf like that?
No. So at the port, we had to basically go through customs just to quickly like show them who we are. And then we got these IDs. Oh, I don't have mine with me, but we got these IDs that basically give us like a pass to like go up the gangway and back down if we needed to leave. Because we were on the ship for 5 days before we left port, those passes helped us like go to the supermarket and start packing some extra supplies we wanted and or go into town to eat dinner. So no one can just go on to the gangplank. You have to like have a registration with the port if you were, and or go through customs like I did. And then this is an image of us getting our food delivered to the ship. So Intier is our partner company who makes sure that we actually have food on the ship, and we have 4 meals a day ready to be eaten and cooked, and the dishes are cleaned, our rooms are cleaned, our laundry is done. So Intier is extremely valuable to the way of life on the ship. And so down at the dock, you can see our camp boss in the black shirt. He's not wearing the yellow vest. He's right next to them. And CM wearing, so CM is another company. So the people wearing red jumpsuits, they are in charge of making sure that anything that goes on through the ship goes on to the ship safely. So they operate the crane and all the heavy machinery. So they were both down on the dock, making sure that this food can go from the dock onto our ship into our storage and our refrigerators. All right, and I learned that we ordered 16,200 eggs.
16,200 eggs for how long will you be at sea? For 2 months at sea. Whoa, I'm gonna, after we're finished, I'm gonna have to calculate how many eggs per person that is per day. That seems like a lot of eggs.
Yes.
So you said the ship was at the dockside for a couple of days before you actually set out to sea. Is this sort of what's happening during those few days, that supplies are being loaded, that final preparations are being made. What's a typical day like while the ship is still moored at the dockside?
Yeah, so again, like I said, for the scientists, because we're the ever-changing group that comes onto the ship, the crew with CM and Tier and the marine techs, the technicians that make sure that all the scientific equipment are good to go, they actually come back to the ship every 2 months. There's 2 rotating crews. So like, let's say crew A will sail this expedition, but they will take 2 months off for vacation and then come back after 2 months. So they know the ship a little bit more. So they're in charge of making sure that all the inventory, all the equipment is worked. If there's any parts that we need to order. So that's what's happening in port for them. They're like making sure everything is coming, leaving. We're dumping our trash. We're getting new chemicals that we need for waste management treatment or desalination to make drinking water during the expedition. But for the scientists, because we're ever new, we're doing basically the onboarding training. Do you know where all the fire exits are? Do you know what to do during a fire drill? Do you know what to do when you need to get off the ship? How do you get off the ship if there's an emergency? You need to meet all the teams, so like the sailing team, and we do a tour of the ship. We learn about what our deliverables, like what we have to complete by the end of the expedition is. We learn about the procedures of drilling. So we basically are treated as newbies, and we're like, all right, this is everything you need to know to make sure you can do the 2 months. So for us, it was about from like 8 to 4, just learning. And then the crew was putting things on, taking things off, putting things on, taking things off. And then this is just the ship in port in Naples. As you can see, during night, we actually have light everywhere on the ship. And so in the middle of the Tyrrhenian Sea or any ocean that we're in at night, we are the light source. We're the light pollution of the ocean. So mainly for safety, we have to be able to see everything on the ship when it's dark, especially with the fact that we're operating heavy equipment and people are wandering around, and we want to have enough light to see where everyone's going with the cameras that we have on board. So we have to stay lit at night. But this is, like, you can see like a day-night comparison.
For any students who are watching who are new to the JOIDES Resolution, the ship has a very distinct profile. It doesn't look like a normal ship. Can you sort of talk about the distinct element of this ship? What makes it special?
Me?
Yeah, besides you, definitely you. And what else?
So essentially, you probably see the biggest thing right in the middle of the ship, and that's our derrick. So that is what makes ocean drilling possible. It holds the 2 pieces of equipment that can pull on the drill pipe, and then it also has the other piece of equipment that can turn the drill pipe. So it kind of like has 2 things that work with it. And so the derrick is in charge of that. And then the other parts are our captain's bridge, which is basically a really wide part in front of the ship, which you kind of can see in the night picture is the orange part. All those orange lights is where the captain's bridge are. It's like really, really big. And all they have is just windows in front of them so that they can see as much as they can to sail the ship. And the other parts of the ship are the cranes. Like, we have, I think, about 4 different cranes on the ship to be able to move things from different parts of the ship, from here to there to there to here, under the ship, above the ship. And I sit right next to one of the cranes, so I can see them every day, just like moving things around. It's hard to not get distracted because I'm like, what are they doing now? And then we have a helicopter pad at the back of the ship, which, again, as you can sort of guess by the name, that's where a helicopter would land if we had an emergency, let's say medical evacuation, where we would have a helicopter come take that person back to land if we're close enough to land. But it's also to be used while we're sailing. We can use it as a way to go running outside or take some nice pictures of the sunset or sunrise. So those are a few profiles of the ship that are very distinct. So on the right side, you can see the derrick, and that picture is taken from the helicopter pad. So it's very, very green. And on the left side, you can see us wearing our life jackets. So this is during a safety drill. So every Sunday, we have to do a safety drill to prove or like practice where we need to go if we needed to evacuate the ship, and like what we need to wear and how do we have it. So we do that every Sunday, and we learn a new thing about the safety and evacuation practices. Like we went into one of the life rafts one time, and then another time we learned about how to like release them, and then so on and so forth. So every weekend we learn about our safety processes. And this is just a beautiful picture of the derrick during a really, really bright sunny day. So the derrick itself, with the height of the ship, can be upwards of 80 meters or about 220, 230 feet tall. So it's pretty tall. Unfortunately, we cannot go up there as scientists, but the CM crew who are in charge of the drilling operations, they do go up all the way to the top to make sure everything is like operating, like the pulley systems are not rusted or breaking, and all the wires are connected where they need to be connected. So this is a picture of Larkin and I in front of the derrick, so closest to the drilling floor. And you can see there's this like yellow machine right behind us. That is one of the things that can actually add additional pipe to the drill pipe. So it can like flip out, and then we'll take pipes that are lying at the back of the ship. They will be moved forward. It'll come down and like pick it up to make it vertical. And then we'll like move the pipe into the hole that we have in the ship that allows the pipe to go through us down to the seafloor.
All right, very cool. Well, you had shared, I didn't have enough time to add a couple photos from inside the ship, but we'll share them next time because you have been not only working, but living on this ship now. You have successfully left port in Naples, and you have been at sea for how long now?
We have been at sea since February 14th, which we should be in our third week now. So just over 20 days, I believe.
All right, great. I want to talk more about everyday life aboard the ship, but we have a classroom, Mr. Mosley, Mr. Gardner's class, that's sitting very nicely and eager to ask some questions. So why don't we pause for a couple student questions? Mr. Gardner's class, welcome, first of all, Kittredge Magnet School. Great to have you here. Are there any brave students who want to ask the first question to Tessa?
I'll try my best to answer.
She's very nice.
Stand up and speak up.
What do you do on like a day-to-day basis when like you're working?
Yeah. So as an outreach officer, my kind of realm surrounds events like this. So I'm frequently working on getting content and like imaging everything that's happening on the ship to post on social media to help people follow our updates of the ship. So I have like 4 different phones with me, cameras and tripods and everything. So I run around the ship to kind of like get images of what's happening. I also run around the ship to interview people who live on here to try to get like their stories and kind of like write up their stories so that we have information about the expedition even when the expedition ends. So that's sort of just like me. But the scientists, they basically wake up and immediately go to their lab and try to figure out what the previous shift was doing to know like, all right, where did you stop on this core? And then what do I need to do? So like what machine does it need to go into to get analyzed? What samples need to be done? So they're consistently talking to each other to figure out what work needs to be done. If you're an electrician on this ship, you're working with your team to figure out what electrical problems might be having or checking that there are no problems. We don't want any problems. So they kind of go around doing maintenance. The rig crew wake up and immediately jump into making sure the drilling floor is doing what they need to be doing. So if we're needing to put in new pipe, they'll jump into that process of working with the different equipment on the rig floor. So everyone kind of has a different day-to-day, but we all come together, which is really nice, at our 4 meals. So I always get to see everyone at our meal time, which like my breakfast is someone's lunch just because we are on different shifts. But that would be an example of some day-to-day.
Yeah, great. Thanks. Great question. Before we take the next question, Tessa, can you tell us what you mean by shifts?
Yeah, so there are 4 different shifts that you can work on the ship. So you can either work from midday to midnight for 12 hours. You can work from midnight to midday for another 12 hours. You can work from 6 a.m. to 6 p.m. or 6 p.m. to 6 a.m. So there's 4 different shifts that someone can work on this ship. And the way that's organized, like who gets what, is essentially by like who you are partnered with in your bedroom. So we always have roommates. So my roommate would be midnight to midday. That's when they would work. And I would work from midday to midnight. So even though we share a room, I never see them because when I'm working, she's sleeping, she's using it to go read or do whatever she wants. And then when she's working, I'm using it to like go read, talk to my family at home, kind of thing. So you have a bunkmate, but you never really see them in the room when you're using it.
All right, thank you. Looks like we have our next question from Mr. Mosley's class. Go ahead.
Hi, my name's Caduce, and my question is, has anything happened so far that's prevented you from working?
Yes. Scientific ocean drilling, as much as we take as many precautions as possible. For instance, for us to do this expedition, we did 10 years of preparing for this expedition. So the first proposal for this ship, for this expedition, was given in 2015, I believe. And they've been working since then. We work with Environmental Protection Department and so on and so forth, and like Italy's team, and we make sure everything is going. But there's always surprises. We never know what might happen. So for instance, like bad weather can really change the expedition's route or drilling agenda. So for us, we were drilling into the ocean floor and the drill pipe got stuck. And that usually happens when something in the borehole, so the hole that we create, like shifted and like maybe fell in on the drill pipe. So we had to stop drilling in that location and just move away to another one. So when that happens, a lot of things stop because we have to make sure, is the ship going to be safe if we try to like remove this drill pipe? How do we remove the drill pipe? And so like a lot of the scientists just kind of like keep doing what they were doing, but all the rig crew and the operations team are making sure that like they stop their progress and go like, okay, how do we get out of the hole and what do we need to do to get out of the hole and move away to another drill site? So sometimes the agenda does have to change, and every day we learn more information. So that's an example. Like when the drill gets stuck, we have to change the way we're drilling and get the pipe out.
Yeah, wonderful question.
Thank you.
Great job. Any other questions? All right, yeah, go ahead.
What's your favorite part about your job?
Oh, my favorite part? There's a bunch of different favorite parts. So like the fact that I work on a ship with 118 fantastic people. All of them are so cool and really love being out here. And the scientists are just so excited about what they're doing. So really getting off of that energy and getting to know them. And then being able to see the ocean is my favorite part. I'm the happiest when I'm on sea. Tim, do you think I could like flip my camera?
You definitely can. You're going to give us a view out of your window?
How do I flip my camera?
Oh, sorry, you can't do it on StreamYard, but if you have like a device, you can just sort of take the camera.
I'll just face it. This is my favorite part. So this is my view of the Tyrrhenian Sea right now. And then you can come out here to sit like Milena is. And yeah, so this is what I like to see.
All right, just a good reminder that even though it looks like Tessa's sitting in a regular office, she is actually in an office on a ship in the middle of a sea. Do you see any land, or have you seen any land since you've left Italy?
Yeah, so like very briefly, we were really close to one of the islands in the Tyrrhenian Sea. So there's like Italy right here. Let's say like my arm is Italy. Right, my arm is Italy. There's 2 islands like right here called Corsica and then Sardinia. So we were really close to Sardinia. At our last drilling site, so we kind of saw a little bit of the mountains. I thought they were clouds. They were not.
All right. Thanks for showing us a little bit of the sea. Do we have another question from Mr. Mosley's class?
Yeah.
All right. Go ahead.
What's like the goal of the expedition?
Perfect. I'm ready for this. Thank you for this question. So the goal, so the general purpose of IODP, which is the forerunning group of scientific ocean drilling, is they want to understand more about the Earth. Specifically, how does the crust act, behave, change, move, shift, cause stress, cause earthquakes, cause volcanoes, bring mountains. So they want to understand all of that. So to do that, each expedition has its own focus because it's hard to do all the science in just 2 months. So our expedition is looking at the Tyrrhenian Sea specifically for 2 characteristics. The Tyrrhenian Sea and the Italian continent are on the same plate. So tectonic plate being the puzzle piece of that area. And so by looking at the continent of Italy and the continental crust that makes up Italy and the transition into the Tyrrhenian Sea, we can start to look at what changes about that ground. Why is this crust looking like this, and how does the crust look like this over here? So we want to look at that transition. So we'll do multiple drilling sites at different areas in the Tyrrhenian Sea to kind of get that view. The other part is to look at the mantle. So in the Earth is made up of multiple layers. We have continental crust on the top layer, and then as we move in, we go into the mantle, and then as we go into another Earth layer. So the mantle, the upper mantle, typically on land is 30 kilometers deep, and 30 kilometers in miles is about 18 miles deep. It's really, really hard to get to mantle when we're on land. And because continental crust is really, really hard rock, our equipment would wear down, would kind of break down sooner than we would get to the mantle. But in the Tyrrhenian Sea, it's less than a mile below the ocean floor. It is actually, let me do this. It's actually 0.1 miles away from the ocean floor. So it's really, really easy to get to. All we have to do is just drill through water, and water is much softer than hard rock. So we want to look at the mantle that has been sort of close to the surface of the sea floor and understand what does the mantle look like, because it's really hard to drill mantle. So our knowledge of mantle is very limited. And so we want to look at what it looks like fresh, how it gets affected by seawater, and that will help us understand better plate tectonics and how earthquakes could lead to, how tsunamis can lead to. Because if we know the composition of what the rocks are made of, we might be able to understand what happens when they get under stress. So that's our goal.
Yeah,
what does the seafloor look like?
Great question and great answer. What a great description of the work being done aboard the ship right now. Excuse me. Do we have another question from Mr. Mosley, Mr. Gardner's class?
I don't think we don't have another question right now.
All right, very good. I'll move you backstage quickly and work in a couple questions we have in the chat for you, Tessa.
Those questions are a little tough. So
the students are ready to get into the science. I think we've got a group here that really wants to know exactly what's happening here. We have a question from Ashlyn, Mr. Chavla's class. How many continent-ocean transition zones have you studied?
So I haven't specifically studied any transition zones, but I had so when I saw this question, I quickly texted the expedition project manager to understand what transition zones have been looked at. And there's actually very few, probably around 4 that the ship has looked at more closely or gone on an expedition to. But what's really fascinating is our continental ocean transition in the Tyrrhenian Sea is quite unique. And there's very rare instances where we think it looks similar to other ones. So we want to understand why this one's so different from all the other ones that we've seen. And that will help us better understand sort of the existence of these continental ocean transitions, because again, we want to know how they transition, but if they're always different, then we want to know all the options for them.
Great. This sort of leads into a question from Grace. Why are scientists curious about areas where the plates come together? You touched on that a little bit.
Yeah, and I'll try to touch on this a little bit more, but I'll get more answers from the expedition and co-chief managers who will have better answers. But when we think about tectonic plates, you want to think about there's sort of two actions that can happen. They can actually hit each other, and one can go under and become a subduction zone, or the other one, they can hit each other and start trying to push against each other, and that's how we get mountains and possibly volcanoes. So those boundaries where those two tectonic plates meet create a lot of events. And we suffer from those events. And I say suffer in like a good and bad sense. We suffer because we get mountains, but we also suffer because we can lead to earthquakes or tsunamis. So understanding what happens at those boundaries is really important, especially as rocks change and events that have existed in areas, because that's now how we know, like, California has a lot of earthquakes because they live on a boundary, and we keep seeing that evidence, and we can see evidence of that in the rock. And we can take that knowledge and look at rocks other places and be like, oh, this has similar stress signatures or signs of earthquakes. This area must have had an earthquake at that time. So looking at how plates act with each other can help us understand what events have happened, what events could happen. And another action of plates is they can actually move away from each other. If they move away from each other, like in the mid-Atlantic ridge and the Atlantic Ocean, those two plates are moving away, you actually can generate new crust. So you're actually seeing how new crust can form. And then one expedition that I was on studied how that new crust changed over time. As it got older, what does it look like? And does it get harder? Does it handle stress better? Does it get more fragile? So knowing those areas is quite important, as much as looking at the middle parts of the plates.
Okay, wow, amazing. And just seeing that beautiful sort of seascape that you showed us from the balcony outside of your office, do you have any sign that so much activity is happening beneath you, or is it just a calm sea? And if you didn't know better, you would have no idea.
Just a calm sea.
Amazing. All right. Brady would like to know what kind of rocks and minerals you are either finding or expecting to find.
Yeah, so this expedition, like I said, wants to look at mantle. And mantle is essentially fresh mantle or pristine mantle is called peridotite. And so the scientists really want to see peridotite because we can get access to mantle, pieces of mantle on land. Like I said, it's really hard to get to. But when we do get access to mantle, it's very altered. It's very affected because maybe it's like a piece of a rock of the mantle and it came through the continental crust. And it's gotten altered by all the weather and all the oxygen and other things happening on land. So it's become a different stage of mantle rock. So looking at peridotite, it's like the freshest of the mantle. So think of like when you go to a bakery and you want to get the first bread out of the oven because it's nice and like it's looks good, it's still crunchy. It's the same thing for the scientists here. They want to look at the peridotite like straight from the mantle, almost as fresh on geological time. So like within 50 million years. And so when they see that, that's one example of a mineral. Other rocks, so like oceanic crust is made out of basalt. It's called basalt. It's just what we expect to find at the bottom of many ocean basins. Like in the Atlantic Ocean, you should find basalt because that's what new oceanic crust forms into. It like turns into basalt. You can also find remnants of volcanic explosions. So when volcanoes explode, they like release the magma and the lava, and they explode and they shoot things into the air. Those things that go into the air go on land or go into the ocean. And so we are getting evidence of possible volcanic like pieces of those things. And then we're also getting views of where there might have been like landslides. So stuff that typically is always on land and is now in the Tyrrhenian Sea. So we're now getting view of like, oh, something has been continually reintroduced, like sand and what's in the sand. So I don't know all the names of the minerals, but we've been getting a little bit of basalt. We've been getting a little bit of peridotite. We've been getting some what they call volcanic clasts or glass. We've also been getting a lot of like really, really soft sediment like clay. And then yesterday, one of my petrologists who studies hard rocks finally saw zircon, which is her favorite mineral. So she was very excited. So a few different ones.
That is amazing. And in our next live stream, hopefully we can get into the lab and see a couple of those samples that are coming up from the seafloor. That's amazing. It's almost like you know a little bit what to expect, but there's also lots of room for surprises.
Always.
All right, fantastic. Taylor would like to know, can you use the information that you're gathering with this expedition to learn about tsunamis particularly? How does that work? How is it related to tsunamis?
I'm not entirely sure how much of this information can be used for tsunamis, so I'll have to come back to that question. But like I said, with sediment, so our sediment cores. So when I say sediment, I want you to think of the muddy, sandy stuff that is always at the bottom of, let's say, like a lake, or in our case, ocean or sea basins. It's all the stuff that it floats in the water and kind of goes down to the bottom of the ocean, and it makes layers. So our sediment cores are showing records of things consistently falling into the Tyrrhenian Sea. So bringing stuff from land into the ocean. And the size of those intervals can indicate a drier period of those events or a wetter period of those events, potentially. So I don't know about a tsunami, so I will check. But we can use those sediment cores to just kind of understand what other weather events are happening.
Super cool. Mason would like to know, and you touched on this again a little bit before, how do you know if other continent-ocean transition zones have the same characteristics as the one in the Tyrrhenian Sea?
Yeah, so essentially you want to think about when we go scientific ocean drilling, we're always doing it in very specific areas of the basin. So for our expedition, we're going almost we're doing a horizontal, a west to east transect of drilling, and then a north to south sense of drilling. So we're kind of getting a view from over here, over here, over here, over here, of what the sediment and the rocks can look like. So essentially, when we look at those rocks, we're looking at very internal structures within those rocks. So I'm always it's a rock, right? You look at the rock and it's ta-da, a rock. But they look at the rock, they look at the rock very up closely with magnifying glass. Then they cut slices of that rock and look under a microscope to see if there's anything changed. And apparently there's a lot of very microscopic changes to the way the rock was formed. Did it go out this way? Did it get enough stress where it broke? Did it layer horizontally? Did it layer vertically? And so all of those little changes gives us a view into what was happening into the basin. How did the continent move away from those two islands, let's say in Italy? So what we would expect to do in other areas is we would try to see if there's similar characteristics. Like I said, is it layered this way, this way? Or is it with class? Is it rounded? Does it have same alteration, what they say, the way they change? So they would look for similar characteristics of the rock as it formed. And I would imagine that's how they would try to apply it to those other areas.
All right, very cool. Well, Mr. Moses' class, I want to give you the chance, if any of that has inspired any more questions, just wave your hand. I can see you. If not, that's perfectly okay. I wanted to ask Tessa, I can see in your background that there is a TV screen and there seem to be people moving on it. What are you looking at on that TV?
So on the ship, we can always have a view of the rig crew. So what's happening on the drilling floor. So let me get a little closer for you. So I'm always watching what they're doing. So right now they're getting ready to take out the drill pipe of the sea floor. So bring it back up. And then we're actually going to get ready for a process called a re-entry cone. So putting down a funnel into the seafloor bed to make it easier for us to drill pipe, to send drill pipe down into the ocean floor, but then also come back to it if we need to. So they're probably doing that. We're getting rid of that pipe. And so I can see the rig floor from my office, just in case. So, which is really helpful because there are times where I'll be working. I'm they're doing something really cool. And I'll run out to go take a picture or a video or ask someone what's happening.
Great. I'm going to work in a couple more questions here. We've got a couple more minutes to go. Kylie would like to know, have you ever seen an underwater volcano?
Personally, I have not seen an underwater volcano. But the ship did go off the coast of Greece last year for one of the expeditions to physically drill into an underwater volcano, like an extinct one. So it wasn't active anymore, but they wanted to drill into it. And it was like very close to the coast of Greece, and they could see Santorini. So the ship has gone to an underwater volcano, extinct one, but
it seems like the JOIDES Resolution likes to seek out the really interesting parts of the ocean floor where there's a lot going on.
We go everywhere. I can show you an example. I have a map here of all the places where we have gone. So all these little dots on the map are examples of where scientific ocean drilling has gone into the world, and where they've been for the different programs that have existed for this ship. So you can see, like, I'm from Brazil, so you can see next to Brazil, there's been a lot of expeditions there or drilling sites there. There's been down south, also been up very much north near Greenland. So we have gone everywhere. And what's really fascinating is I was talking to the expedition manager. I was like, we keep getting new rocks, like not new rocks, but like rocks that don't look like the way we think they would look like. And she's like, yeah. I was like, this is so weird. I'm like, you start out an expedition and being like, yes, we're going to look at ocean rocks. And then every ocean rock looks like has something new to say. So it's awesome because you get to keep asking questions and keep learning and just keep seeing how the earth is.
Very cool. Always something new to discover. I think I see another question from Mr. Mosley's class. I'm going to bring them up. Go ahead.
What was your inspiration to be a scientist?
Yeah. So I absolutely love sharks. And when I was younger, my brother told me that I needed to go into marine science to study sharks. So that's what led me into the science world. And then I learned that I really just liked seeing all these little cool discoveries, and the ability to ask questions and the freedom to ask questions in the science world is so great, because I can go and see, like, why does it do that? And then the scientists will come to me, they're like, I don't know why it does that. That's why I want to study it. And so no question is too small in the science world, which is really, really great. But I was talking to one of the petrologists, and he got into geology because he just always loved looking at rocks when he was younger. He would go to the riverbeds, the ocean, like the beach, and then just like pick up rocks and just keep looking at them. So it was a passion of his as well.
All right. Fantastic question. We have, go ahead, Tessa.
I was just going to say, there's also people on board who discover geology like later in life. Like they were in college and then they discovered that they actually liked rocks, because every other science didn't really fit right. So just wanted to emphasize that it doesn't have to start out with a passion from when you were a child. It could be something that you discover later in life.
All right, great. We have 1 more minute left. Any other questions for Mr. Mosley, Mr. Gardner?
Go ahead.
Oh, great. We've got a hand. Excellent.
What qualifies you to go on this expedition?
Fantastic question. Oh my gosh, yeah. You guys are really keeping me on my toes. So because we are working, so technically there's those 4 companies that we work with to make sure the ship works. So CM Offshore is looking for people who can be engineers, drillers, tool pushers. These are the actual names of the jobs. Roughnecks. So like there's qualification being like a mechanic. There's qualifications for being an electrician, a sailor, a captain, a first mate. And then for scientists, the way it works is you actually have to apply to sail as the position on board that we have. So we have a certain number of places for sedimentologists, a certain number of places for petrologists, a certain number for micropaleontology. So like based on your background and skill set, you would apply and say, this is what I want to do on the ship. This is how I would use the data, because you actually want to come in with a project proposal. Like, I want to learn about these things when we go out there, because the point of coming out as a scientist is you're actually going to do research and like publish your findings. So they get looked at with their skill sets and what things that they could be bringing, what expertise they can be bringing based on the expedition goals. So they apply. And then the marine technicians, it's another like a job application where they like apply and say like, this is why I want to work on the ship. This is what I could learn. This is what I already know. And they work to make sure all the equipment works on board, like our X-ray machine or imager machine or our X-ray diffraction and X-ray fluorescence. And so there's a few different things, but it basically largely looks at like your skill set, like what skill sets do you already have and what skill sets can they teach you.
All right, thank you, Mr. Mosley, Mr. Gardner's class at Kittredge Magnet School. Great questions today. That is about all the time we have, and I know you need to go on to the rest of your day. So before we say goodbye to you, maybe you can give a big wave and thank you to Tessa for joining us today.
Thank you everyone for your time. You all had great questions, and thank you to everyone who joined that I didn't get to hear your questions too.
Yeah, thanks for joining. I'll move you backstage. Have a great day. Tessa, thank you so much for everything you've taught us about the expedition so far. In like the last 30 seconds, can you give us a preview of where we're going next? What do we have to look forward to in the next 3-4 weeks before we speak to you again through a live event like this?
Yeah, so we have more drilling locations where we're going to go get some more hard rock and more sediment. We're going to go, I'm always looking at the drilling floor to see what they're doing on the rig floor and making sure I'm understanding what it is. So I'm happy to talk about those processes. And then we'll also look at how the labs are doing with all the data that they're collecting and all the different equipments that they're using. Like the chemistry lab does one thing, the coral lab does another, the sedimentology does another. So always fun to be seeing what they get up to.
Very exciting. Well, if anyone who's watching or is going to watch the recording hasn't seen it yet, Tessa and her colleague Larkin have been publishing some amazing articles on their Reach the World homepage. There are many more to come about all aspects of this expedition. As Tessa mentioned, we're going to be going into the science lab in our next live stream. So you'll get to see more of that very active area aboard the JOIDES Resolution. And there's a lot to learn still as part of this expedition. So even though we're out of time today, the virtual exchange is ongoing and will keep going for quite a while still. And with that, we have to wrap it up. You've got other things to do. So Tessa, thank you so much for joining us today. And I look forward to seeing you again soon.
Thank you. See you later. Have a great day.
You too.
Bye.